Hello everyone, you are all welcome to lecture number 920, and today's topic is the manufacture of ALDRIN and DIELDRIN. These two organic chloro derivative of bicycle and also 5-member cycle derivative was prepared in 1949, and it is very effective against insecticide and pests, especially the soil insecticide, cotton insecticide, grasshoppers, and it is very toxic also, and it can irritate your skin, eye, and it is also toxic and poisonous to cold-blooded as well as warm-blooded, means marine animal as well as human being. And that's why the ALDRIN and DIELDRIN has to be used very carefully and with restriction. Nowadays globally these two insecticides, since they are very toxic, it is not widely used because it has some toxic effect on food grain. So that's why its use is restricted. And ALDRIN is prepared from that is your hexachlorocyclopentadiene derivative, or we can say hexachlorocyclopentadiene, and these derivatives are subjected to reaction, chlorination, further chlorination, and it is changed into bicycle with the help of Diels Alder addition reaction. And that's why, because of that Diels Alder reaction, they are known as ALDRIN and DIELDRIN. So here the reaction is given, that is your cyclopentadiene. This is your cyclopentadiene, 5-member ring, and it is subjected to chlorination. And once it is subjected to chlorination, it is changed into tetrachloropentane. So that tetrachloropentane is further subjected to chlorination at about 352 even 500 degrees centigrade temperature, 352 even up to 500 temperature, and then it is converted into hexachlorocyclopentadiene. And this hexachlorocyclopentadiene is again treated with cyclopentadiene, and it is subjected to chlorination, and the one product you will get that is your chlorodaine. This is your chlorodaine, which contains 6 plus 2, 8 chlorine, and when it is treated with SO2Cl2, that is the source of chlorine, then it is converted into heptachlor. So these two are very important condensation of two ring. One is cyclopentane, other one is cyclohexane ring, and one is called chlorodaine, other one is called heptachlor, and this is subjected to Diels Alder reaction, that is your heptachlor. And once heptachlor is subjected to Diels Alder reaction, it is converted into ALDRIN, and this is your ALDRIN. And when this ALDRIN is subjected to oxidation, and epoxidation will take place, and epoxide is formed here, and the formation of epoxide, that will give you DIELDRIN. So in this way we can manufacture ALDRIN as well as DIELDRIN organic chloro insecticide. So in 50s and 60s, when ALDRIN and DIELDRIN was commercially manufactured, was a big news globally because it was very powerful insecticide, very effective, and that's why it became very, very popular very quickly. Number one, both ALDRIN and DIELDRIN insecticides were manufactured in the year 1949. ALDRIN. So the ALDRIN, if we are writing, it's all bicyclic substituents, chlorine and all those bonds and their structure. We can write like this, specifically 1, 2, 3, 4, 10, 10, hexachlorocyclopentadiene, 1, 4, 4A, 5, 8, 8A, hexahydronaphthalene. So this is the exact name of ALDRIN. Number two, commercially ALDRIN is manufactured by hexachlorocyclopentadiene, and that is commonly known as hex. And I have already shown in the beginning all the structures and their reaction. Here just I have written the same thing what it was explained in the beginning. And bicyclo 221 heptadiene 25 through Diels Alder reaction. So these two nucleus, they are condensed, and that condensation is by Diels Alder reaction. The excess of bicyclo 221 heptadiene 25 is mixed with hex. Hex means hexachlorocyclopentadiene, and the mixture is reflux for 12 to 17 hours. The cyclopentadiene is prepared by Diels Alder addition of acetylene to cyclopentadiene at 50 degree centigrade temperature and under pressure of 80 pound, that is not 80 pound, using a contact period of 2 minutes to 3 minutes. Number 3, ALDRIN can also be obtained by the reaction of bicyclopentadiene, that is bicyclo penta is twice 10 bicyclo. So bicyclopentadiene, that is diluted with equal volume of hydrocarbon and acetylene at 200 degree centigrade temperature and 200 atmospheric pressure. The product is bicycloheptadiene, that is your ALDRIN. Number 3, ALDRIN has a light tan to brown color. Its specific gravity is 1.6 at 20 degree centigrade temperature. Its chlorine content varies from 59 to 75%, and it is immiscible with water but miscible with acetone and aromatic hydrocarbons. It is stable to heat, alkali and dilute acids.